Lesson 7-1, Multiplying Monomials, Day 2. Our essential question is, how do you multiply monomials? We learned three properties in the previous lesson, Day 1, 7-1, Day 1, and we're going to use those three properties again today so you don't have any new vocabulary words. So we're going to go right into some examples. Simplify the expression. 3 to the third power to the second power. So 3 to the third power, you have a couple of different options on this problem. If you want to use PEMDAS, you could do 3 to the third. 3 to the third means 3 times 3 times 3. So 3 times 3 is 9, times 3 is 27. So you could do 27 and then bring down the second power. So then it's 27 to the second power, or 27 times 27. So that would be 729. So that's one way that you could solve this problem. Another way would be to use the exponent rules. One of the ones that we talked about yesterday was called power of a power. If you use that power of a power rule, it says you can multiply together these exponents. So then it would be 3 times 2, which is 6, or 3 to the 6th power. So I don't know if that would be any easier than multiplying 27 times 27, because up here we had 3 times 3 times 3, so 3 to the third is 27, but you'd have to do 3 more. So either way, your answer is 729. The next one, if I use PEMDAS, I would start on the inside parentheses. 2 to the second power is 4. And then I would work my way out. 4 to the third power, 4 times 4 is 16, times 4 is 64. So 64 to the second power. And then I would rely on my calculator so that I didn't have to multiply it by hand. And that's 4,096. 4,096. Now, solving the same problem using that power of a power rule, I can multiply together all of these exponents. So 2 times 3 is 6, times 2 is 12. So 2 to the 12th power should give me the same answer, and it does. 4,096. So either using PEMDAS, working your way from the innermost parentheses, working your way innermost parentheses to the outermost, or using the power of a power rule. Okay, our next problem. This is another review from what we were doing yesterday. So now we've got the product of powers, So first I want to remind you that you could expand this to look like this. Negative 4x to the third means negative 4 times x times x times x. Negative 8x squared means negative 8 times x times x. Then, because they're parentheses next to each other, you're multiplying them, you could rearrange the order and multiply together the two constants to get your coefficient 32, and then multiply all of your x's together, and you see that you have 5 of them in all, so 32x to the 5th power. This next one, I'm going to do the same thing. So a times b to the third looks like this. 5a to the 5th. b to the second looks like this. Then if you rearrange the order, we would actually want the 5 first. And then we would want to count how many a's we have. There are 6 of them. So a to the 6th. And then count the b's. 3, 4, 5 of them. B to the 5th. Remember that the shortcut we said, what you could do is you can multiply together your coefficients. You could add together those exponents, as long as the base is the same. So multiply coefficients. This one would have a 1, so 5 times 1 is just 5. Write in your 1 on the A. You could add the exponents on the A's. You could add the exponents on the B's to get your answer. So that's using the product of powers. Now we've got our power of a power. So this is where we can distribute and multiply it. So we would get 2 times 2, our m to the 4th power, and this works because the outside exponent means you're multiplying it by itself. So you could write this twice if you wanted to and expand it to get the same result. So the outside exponent means what's inside gets multiplied by itself, and the outside exponent's 2, so multiply it by itself twice. This next one has an outside exponent of 4, so we would have to multiply it by itself 4 times, like this, 4 of them, or use the shortcut. It's your choice. So I used the shortcut on the first one, so on this one, I'm going to write it all out. 2 times 2 is 4, times 2 is 8, times 2 is 16. And then 1y here, 1 here, 1 here, 1 here. So 4 all together. And then z's, 2, 4, 6, 8 of them. Like that. If you distribute on your shortcut, just be careful and make sure that you're including everything, the constant and each variable separately when you distribute. Okay, now we've got one of those power on power. In the parentheses, the innermost parentheses, this is my term. The exponents outside, 2 times 3 is 6. So I'm going to multiply those together so that now I only have to distribute a 6 to everything. So 2 to the 6th power, x to the 6th power, and y to the 18th power, because 3 times 6 is 18. So if your term, if your constant or your variable has an exponent on it already, you have to remember to multiply the one from the outside when you distribute. So 2 to the 6th power is 64. So my final answer is 64, x to the 6th, y to the 18th. Oh gosh, this one's got a lot going on. Okay, so for starters, I'm going to take the 2 and distribute over here. So 3 to the 2nd power, x to the 2nd power, y to the 8th power, or 9x squared, y to the 8th power. Then I'm going to switch colors for you, and I'm going to remind you that in these parentheses it's negative 2y, so the 2 and 3 can be multiplied together to give us an exponent of 6 to distribute. So now I distribute the 6, so I get negative 2 to the 6th, y to the 6th. When you're simplifying this one, it's important that you have parentheses around that negative 2, because an even exponent will give us a positive result. So that is positive 64, y to the 6th. Now these still need to be multiplied together because there were parentheses next to brackets. So 9 times 64 is 576, and then I have x to the 2nd and y to the 14th because I add the exponents on my y's. So I simplified on the left, I simplified on the right, and then I had to put it all together. Because it's all multiplied together, this is a monomial. It's a monomial. It's not a binomial or a trinomial because we have constants and variables all multiplied together. So the final simplified answer is 576 x squared y to the 14th. Next up, we have a geometry kind of a problem. Express the area of the circle as a monomial. Well, area equals pi times the radius squared. So area equals pi times the radius on that picture is 2xy squared and we have to square that. So, distribute, and leave the pi alone. So 2 squared, x squared, y to the 4th. So 2 squared is 4. So the order that you would see this written in geometry class would be 4 pi x squared y to the 4th. And then I'm going to put units squared after it because areas are always square units. So they didn't give us a label like inches or centimeters, so I'll just put units squared. So take the radius, so the radius from our picture right here, and square it because the formula is a equals pi r squared. Then after you square it, take that constant number, 2 squared is 4, and put it in front of pi. And that is your area. That is our last example, so you should be able to write a summary now answering your essential question. Make sure that you use complete sentences and restate the essential question.